So last time we were discussing about some tensor analysis. There is some result, that is, if I have to show that aijk xi plus yj zk, that is not equals to aijk xi zk plus aijk yj and zk. I have to show that this term is not equals to this. So what we have to do is, if you see here, so here is, in that case we have observed on this side that there is no free indices, because I is present here and also here, j is here and k is here and here. So that means there is no free indices on this side. Now let's go on the other side. As you can see, here is the I and here is also I, and here in this term I can say j is the free index icon, and k is present with the a and with the z. So that means j is free indices here, and in this, you can say, in this term I have only I free indices. So on this side, on the left side, there is no free indices, but on the right side I have two free indices. First is j and second is I. So that means that both these sides are not equal. So I prove it generally like this. Next I have Kronecker delta del ij. This is known as Kronecker delta. So Kronecker delta or substitution operator is written generally like this, and it's defined as del of ij is, I can say, 1 if I equals to j and 0 if I not equals to j. This is the basic definition of Kronecker delta. That means if these two indices are same, then I have result that is equals to 1. That means if del 1 1, so then result is equals to 1. If I have del 2 2, so that is also equals to 1. And if I have del 3 3, then that result is also equals to 1. But if I have del 1 2, or I can say del 2 1, then in both cases I have that result equals to 0, because these two indices are different from each other. And as we have above, that if I not equals to j, then the value of the Kronecker delta is 0. So as you can see here, these are the basic values. Now I am going to use these values and solve some question. So I have del ij xi xj. This is the question here, and I have to solve this, that this result is equals to, I don't know, we have to find this result. So what we have to do is, first I am going to expand it like I am open up by summation convection. So that means del ij xi xj, so that result is equals to, I am opening I here only, so 1j x1 xj plus del 2j x2 xj plus del 3j x3 xj. Now in the next step I am going to expand with j. So then this result is del del 11 x1 x1 plus del 1, in place of j now I place 2 x1 x2 plus del 1 3 x1 x3. Now expanding this term, del 2 1 x2 x1 plus del 2 x2 x2 plus del 2 3 x2 x3 plus, now expanding this term, del 3 1 x3 x1 plus del 3 2 x3 x2 plus del 3 3 x3 x3. So these are the results, these are the expanded form of this term. Now applying the definition of Kronecker delta. So if I have same indices, I can say ij if same, then that result is equals to 1. So 1, I am putting the value of del 1 1, that is 1 here. So 1 x1 plus, and del 1 2 is basically equals to 0 x1 x2 plus again 0 x1 x3 plus again 0 x2 x1 plus, in place of here I put 1 x2 plus 0 x2 x3 plus 0 x3 x1 plus 0 x3 x2 plus 1 x3 x3. So these all terms become 0 when multiplying with 0. So I have only x1 plus x2 plus x3 x3. So if I combine this, or I write in summation convection form, so the result is xi. So that means del of ij xi xj is basically equals to xi xi.